All right, 7-2, multiplying polynomials. All right, Harshan, I know you've been out a little while, so I'll give you a recap. Polynomials is just a fancy word for saying like expression with many terms, okay? So a polynomial has a bunch of terms which are separated by pluses and minuses, all right? So we have a binomial, like think of like bicycle. Why is something called bicycle? Well, it's got two wheels, right? So a binomial has two terms. Trinomial, think of a tricycle, three wheels. Make sense? Okay, so trinomial, three terms. Monomial, mono means one, all right? So that would be one term. So here it's pretty straightforward. It's just multiplying monomials. Kind of a combination of the exponents and just, I guess, sort of common knowledge here, okay? You ready for this, AJ? All right, nothing too tricky. Okay, x times x, AJ. You want to take a stab at what x times x would be? X to the second. So it would be x squared. 2x times 2. Sophia, you want to take a stab at that one? Okay, so let's look at number 2. We have 2x times 2, right? So do you see how AJ's was x times x, and that gave us x squared? Do we have two x's here? No. It would be just 4x. All right. So we would just multiply the coefficients together. Okay. So we're going to have two parts to these problems. We're going to have the variables, which will look like number 1. Okay. And we will combine them together. And then we have in like number 2, which Sophia had, we have something called coefficients, which we multiply them together. And the difference is, hey, here, we're going to be dealing with the exponent part. When you have a variable times a variable, the exponent is going to change. But with the coefficient, we're just simply going to do that multiplication. So the question like number 3, we have both things going on here. So I'm going to do 2 times 3, that's 6. And then I have what AJ was telling me, x times x, that's x squared. All right. Now hope yet again at number 4, I'm going to have different things going on. First thing I'm going to tackle is I'm going to tackle those coefficients. So I'm going to do 3 times 2, which is 6. Now I have the variable, and that's x cubed times x cubed. So remember, we're adding the exponents. So it's x to the 6. Okay. All right. Now, normally I let you guys try the you try. All right. But I want to make sure I go over it, thoroughly so you guys fully understand this. So let's look at number 4. In number 4, I have the coefficient. So 10 times 14, that's 140. And now I have a times a to the negative 1. And remember, I add these exponents. So, Nate, what's the exponent of a in number 4? So the trick is there isn't one there, right? So what can we put there? What one number can we put there? Very good. We put 1. So now I have a to the first times a to the negative first. So remember, I add those exponents. So what's 1 plus negative 1? 0. So anything to the 0th power is 1. So it kind of goes away. And then I have b to the first and b to the third. That's just b to the 4th. All right. Jordan, you okay with that a little bit? Neat. 10. No, I'm not going to stop. The capsulate kind of breaking.
Thank you.
Sure. All right, why don't you guys try the other 3 you tries? Matt, how was Laxapalooza? Good time? You want a game? Good. Drew, you all done? All right. Drew, what'd you get for number 1 then? Perfect. Jordan? Perfect. And Delaney. Pretty straightforward, right? Not too difficult. Kevin, you okay with all that? Nice. Okay. So the next thing we have to deal with is multiplying a binomial times like a binomial. So it's pretty simple with this stuff, okay? So basically, once we get out of monomial times monomial, which is just like, kind of like, think of like 3 times 4 or something like that, it's fairly simple and straightforward. We're gonna get into something like, oh, what is 3 times like 10 plus 4? Okay, and we kind of can distribute that. All right, so there's a quick way to kind of memorize how to multiply a binomial times a binomial. It's called FOIL, which stands for first, outer, inner, last. Okay, so again, first, outer, inner, last, and I'll kind of go over that with you. Like, what does that mean? All right. Now I do it 2 different ways, AJ. All right. So I'm not just going to show it all through the FOIL method, because FOIL method is only good for binomial times a binomial. All right. So I'll show it kind of like 2 other ways. Okay. First thing, first. Well, what does first mean? Well, it's the first term times the first term. So I'm going to do x times x. That's x squared. Does everybody see that? Destiny, you okay? Long weekend? Yeah, I feel you. All right. Tough weekend. All right, so I have x times x. They're the first terms. Now the outer terms, Kanye. That's going to be x times 5 because they're both on the outsides. Do you see that? Makes sense? So x times 5 is 5x. Now the inner, that's going to be my inner terms. That's going to be 2 times x. That's 2x. And then the last terms. Harshan, the last terms are the 2 times the 5. That's 10. And I'm not done yet because I have 2 things in the middle that can be combined. All right, that's 5x and 2x, which combine to give me 7x. So this is x squared plus 7x plus 10. Emma, does that make sense to you?
Yeah.
All right. You guys okay with that? All right, so that's FOIL. All right. Now, Delaney, FOIL is like a new term for you, right? But it's the same thing you've already learned. I just gave a name to it. Well, a different name. Delaney, do you remember back in like September we talked about the distributive property? It was basically like, oh, I have a stack of papers. Like, hey, Harshan, can you distribute these papers? And you give it to everybody. The FOIL like method or that kind of like acronym is the same thing as the distributive property. Wow. If I distribute this x, the x goes to the x and the x goes to the 4, right? Do you see that? So x times x is x squared, x times the -4 is -4x. Kind of the same thing we did over here, right? I just called it first, outer, okay? And then I have the 3. Well, I distribute the 3. 3 times x is 3x, and 3 times -4 is -12. And then I combine my like terms here. So I have a -4 and a 3. So this would just become x squared minus x minus 12. See how it's the same thing, Delaney? FOIL and the distributive property. Okay. Now there's kind of like another method that I like. Okay. And it's up to you to figure out which way works best for you. All right. Some of you guys are a little neater. Okay. Like I feel like Hope might like this. All right. Harshan, probably not. Probably not Harshan's thing. Jordan will probably like it. Okay. Kevin's probably like, bro, just tell me how to do it. Let's get this done. All right. So the last one is this. I want everybody to kind of draw a rectangle. All right. And then this is a binomial, right? So it's 2 terms. So I'm going to cut my box in half this way. And this has 2 terms. So I'm going to cut my box in half that way. So I have 4 boxes. Hope, do you see how I did that?
Yeah.
Now, going down, I'm going to write x minus 3. Do you see where I got that from? Going along the top, I'm going to write x minus 6. You see how I did that? Is everybody with me? Now, this is called like the area model, okay? So all I'm going to do now is I'm going to do x times x. All right, I'm going to come up with the area of this little box here. That's x squared. And I'm going to come up with the area of this one. That's going to be x times -6, and that's -6x. -3 times x is -3x. And -3 times -6 is +18. And now the reason why I like this is you can see each term that you should have. You should have all of the boxes filled in. So if you miss a step, it's easy to see. Up here, if you miss a step, it's not as easy to see. It's a little bit more abstract, okay? Now here, this is how I do it, Delaney, ready? First, we start with my largest degree, right? Because I want to write my answer in standard form. That's going to be x squared. I only have one of them, so I cross it off when I use it. Now, I'm going to write my x's. I have -3x and -6x. That's -9x. And then the only thing I have left is the 18, and I write that at the end. That's so my answer is x squared minus 9x plus 18. Easy enough? That wasn't too bad, right? Right, AJ? So we have 3 methods. We have FOIL. FOIL, I don't really like to think about it as FOIL because you can only use it for a binomial times a binomial. All right, it's the only thing it's good for. All right, so most of the time I think of it as distributing. I'm distributing each term into that second polynomial. Then we have the box method or the area model. Okay, that way is nice and clean. It's easy to follow. So you can choose which way you want to do it. All right, I kind of like the box method. It's kind of easy, it's clean. All right. So here, again with the box method, draw a box. I have 2 terms and 2 terms, so I divide it in half each way. I have 2x plus 1 and 3x minus 5. Sophie, what's 2x times 3x?
6x
6x
squared.
squared. So it's going to be 6x squared. Mackenzie, what's 2x times -5?
-10x.
Very good. Angela, What's 1 times 3x?
3x.
Very good. Mrs. Potts, what's 1 times -5?
-5.
Yeah, there we go. You see how I'm coming. It's a Monday. Got to keep you on your
Right.
toes.
Wrote it
All
wrong.
right. Okay. All right, Kevin Camlin. Did I get a good laugh out of somebody who thought that was funny? Nobody? It's okay. All right, Kevin, what's my final answer? What do I start with? 6x squared minus 7x. Ooh, I like that. You did that all in one step, okay? Perfect. Kevin, are you okay with it? Is your twin brother, Kevin Camlin, okay with it? All right, that's good. All right, below it, you guys have how many questions?
4.
4? Can you guys work on those 4? You can do it using the FOIL method, the distributive kind of method, which are kind of one and the same, or you can do it the box method.
Just do the box method. Multiplying on Friday.
I like it. You did it
One of the IXLs, one of the kids was working on.
downstairs.
Yeah, he did use that method. He didn't know it. So
You sure? Undefeated. Told you. I was undefeated. You wanna try again? All right, what do you have to do? You wanna play common knowledge? What is the Eagles draft pick? What? Wow. The school related?
yeah, he was in the meeting actually.
Okay, how many bricks are in the school?
More than one.
I don't know. All right, go count. Go count the bricks, go. Go. That's code for good. Like that one, just came up with it on the spot.
Good job. Good job.
Pretty good. Stole it though from my former woodshop teacher, Mr. Province. Good man. I had to go wait for the fire truck. Was waiting a long time. Neve, you done?
Yep.
Neve, did you get that for the first one?
Yes.
Awesome. Nate, did you get this for the second one? Yeah. Perfect. Jordan, did you get this for the third one? Finish it. You got it? And did you get that? The Y's in the middle cancel it out, right? Nice. All right, any questions on this? All right, are you guys okay with the methods? Like, did you find one that worked best for you? Whether it's the box method or the foil, it doesn't really matter to me. Okay, I would prefer the foil. I'm not a big fan of it. It's just a way to like name it. Okay, so I kind of like thinking of it as distributing or the box method. All right, here's why, Mrs. Potts, I'm not a big fan of the FOIL, because now what do I do when I have a binomial times a trinomial, right? FOIL's only 4 letters.
Right,
Okay, I only have first, okay, I can still do that. Outer, sure, I can do that. Inner, okay, and last, yeah, I can do that, but there's one term that's like missing, I just never really touch upon. So that's why I like to work through the box method, okay, or the distributive method. So here, all right, I'm gonna show you both one way. All right, Kanye, if I am doing the distributive method, this is what I do. Ready? I'm gonna start with the x. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 2 is negative 2x. Does everybody see that? Matt, do you see how I came up with those? Now, I have this 5, so I do 5 times x squared. All right, so I kind of think of like 5x squared. And I'm trying to like, when I'm doing this, and I'm writing it down, notice, what did I do here? This is Potts. What did I do with my x's? You see what I'm doing?
no, I missed it.
Okay. Now I got it.
Again.
Watch. 5 times negative 3x,
Oh, yeah, you
15x. I'm doing what?
distributed.
I am, but what am I doing when I write it? Lining it up. Do you guys see that? It's subtle, but it's
Whoa,
but it means a lot, right?
too subtle for a Monday.
Maybe. I notice I'm lining it up because that's going to allow me when I add my answer, combine my answer, I'm going to have my final answer. I'm not searching around. So notice I'm lining up my axes. And 5 times negative 2 is negative 10. So now when I go ahead and kind of find my answer, remember I'm combining here, right? I have x cubed, negative 3x squared plus 5x, so that's going to be plus 2x squared. It's going to be 13x minus 10. You see that? AJ, you see that? Subtle, right? But that's really easy. Okay. Box method. Okay, box method here. Draw my box a little bit bigger. I have 2 terms. And then I have 3 terms. 3x plus 1, 2x squared minus x minus 6. Hope you okay with this so far? Did you find a method which works best for you?
Yeah.
Which one do you like? This one? Okay. Here, I'm going to do 3x times 2x squared, that's 6x cubed. 3x times negative x is negative 3x squared. 3x times negative 6 is negative 18x. 1 times 2x squared is 2x squared. 1 times x is negative 1x. And 1 times negative 6 is negative 6. All right. Harshan, do you find a method that works well for you?
Yeah.
Okay. Now here, I'm going to combine. I'm going to start out with my largest exponent, that's x cubed. So I'm going to write 6x cubed. Then I'm going to combine my x squareds, negative 3x squared and 2x squared is negative 1x squared. Okay. Negative 1x, negative 18x is negative 19x. Then I have a minus 6. Delaney, do you find a method you like? Okay, which one did you like? The box, okay. So it doesn't matter to me. You find one that works well for you, and we stick with it, okay? And it's the same thing. It's the same thing. Ms. Kendra, which one do you like? Yeah, see? So it all works out for you. So I'm glad you guys found a method. Now use it on the extra practice. How many are there? Like 6?
No, but
All right, work on those 6. So you can do whichever way. Okay.
then it's here, should this be negative? 5 times that is
Oh, yeah. I guess I was, yeah, okay, good catch. Mrs. Potts found a mistake, should have been -15. Thanks, Jordan, where were you on that one? Same place as on the pony rides,
sorry, George.
not there. It's a Monday. It's a lot to expect me to be perfect on a Monday. Like, you're lucky I have 2 shoes on, maybe socks that match. I don't know if they match. Jordan, how were the pony rides? See? You promised to be there. You did. Lamb and you said, well, we'll both be there Sunday. Don't come Saturday, Laxapalooza. Come Sunday. Jordan, when I have you again, because inevitably I'm gonna have you again, okay? It's gonna be the same thing all over. Same thing. I don't have new tricks. Same stories. Okay. Maybe I just use, different people in it.
I have a different job. Just to throw you off.
Doubt it. Doubt it.
We have 2.
Should have 2 jobs. Look, nothing can beat my first job of selling cookies at the mall. Mrs. Fields cookies.
Mine was making fix-it-in toothpaste. on the assembly.
Right.
Cookies would have been better.
Cookies almost like
Could you get?
give me like diabetes. I eat way too many cookies.
All the rejects.
No, I just got to take them because they're throw them out.
I know.
I'll eat them. Then I had to get blood work, and they were like, "Sir, your blood sugar is through the roof." I was like,
Yeah.
I've been eating cookies for 6 months. I don't go to waste. Could have just worked down the line, like, learn some that, learn some that. Whereas, yeah. Yeah, you put this on practice. It doesn't matter which one you stop. I do like the box method. But it's not mine, it's some. Super tired for that. Late night. They told me, they asked for the cheapest one. I said, "We have the white stuff." So I got- now I'm just afraid of it getting there. All right, let's look at these. So number one, right, we have 4n minus 1 times 3n plus 4. That should be 12n squared. And then we're going to have plus 13n minus 4. AJ, is that what you got? Yeah. Okay. All right, number 2, we should have 6n cubed plus 7n squared minus 8n minus 5. Kevin, is that what we get for number 2? Are you sure? Sometimes they just put up wrong answers to see if you're paying attention. Is that actually what you got? Okay, good. Good. All right, number 3, negative q squared minus 2q minus 1. Neve, is that what we got?
Yes.
All right. Number 4. Nate, you do number 4? Okay, let me know what you got. Nate, did you get h squared plus 2h minus 8? Awesome. And the last 2. Okay. We have 2p squared times 3p. That's going to be 6p cubed. We're going to have plus p squared. And then we have minus 10p plus 3. Ms. Kender, is that what you got? Minus 7p. All right, so let's see. Did you do 2p squared times 3p is 6p cubed? And then you got minus 2p squared, right?
Yeah.
And then we do p times 3p. So that's going to be plus 3p squared. So that gives me the p squared, right? So we're good with the first 2 terms. Now we have negative 1 times p, that's negative 1p. And now we have negative 3 times 3p, and that's negative 9p. So negative 9p and negative 1p is negative 10p. All right, and maybe we'll use that one as a warm up. I'll post your homework. Have a good day.